after we talked about the angles, we talked about the right triangle today, and I want to use a right triangle to explain some trigonometric function. Okay, so it's right triangle. Trigonometry. That's what we're going to learn today. And we know for the right triangle, which means it's a triangle and there's a 90-degree here. So that's the right angle, and then you connect the other 2 points. So this is called a right triangle. All right. Now for this right triangle, what do we know? We usually use the lowercase letter to show the side. So this is a little a, this is a little b, and this is a little c. That's what we usually do. And also we use capital letter to show the angle. So we show this is a, this is a b, and here it's a c. All right, so that's the general expression that we use to show this right triangle. And the good thing we know is for this angle A and angle B, because angle A plus angle B plus the angle C, the sum of the interior angles of a right triangle should be 180 degree, or pi. However, since you have a C which is 90 degree, so what you know is A plus B should be 90 degree, or pi over 2. Okay, and later we'll just use A plus B equals 90 degree, or pi over 2. I will write like this instead of having this little angle here. And I think when you take the geometry class, and you probably want to use this, the measurement of angle, So from now on, we just ignore that. We just use the capital letter to show the measurement of that angle. All right, now, since you know this angle A and angle B, add up to 90 degree. And this angle C is a 90 degree by itself. So if I give you one angle A or angle B, you should be able to find the other one. Just subtract that from either 90 degree or pi over 2. All right, now we are going to use angle A as the example to introduce this trigonometry. Okay, now we call this angle A, for this angle A, okay, for this angle A. And this little a, we call that opposite side. Okay, and this angle B, we call this adjacent side. Can you see that? These two we also call the legs of this right triangle. And this little C, this one, I call this as a long side. Just make it easy, but actually has a very interesting mathematical name. Okay, it's called a hypotenuse, or hypotenuse side. All right, now the new game start, okay? Here, sine A. That is a function. Sine is a function. It's a short for S-I-N-E, sine function. So sine of A, which is the opposite over the long side. So that is the A over C. And cosine A is B over C. And the tangent A is the opposite A over the adjacent. So that's the 3 trigonometric function that I'm going to introduce today. This is super important. As you can see that, because the sine A, which is A over C, sine A, which is A over C, the opposite over long. The cosine is the neighbor, or the other leg, the neighbor leg, or the adjacent side over C. Okay, So because A is less than C and B is less than C, A is less than C, B is less than C. So we know that this got to be between 0 and 1. Cannot be 1. It must be in the range of 0 and 1, isn't it? Yep. And then tangent A over B, tangent A, which is A over B, A over B. So that could be, if A is really, really small, B is big, so this number could be close to 0, but not 0. And then if this B, the denominator B is really small, and A is big, so you're going to have something look like this, right? You have a big angle A. So that can be a big number, okay? I just write it like this right now, okay? Or in the future, you probably know, okay, we can use infinity, which means a big number. So those are the three trigonometric functions, all right? Now, what's the other thing that we know about the right triangle? I believe that you're going to tell me is the Pythagorean theorem, which is a squared plus b squared equals c squared, right? Okay, so that's the a squared plus b squared equals c squared. So we know this, okay, and we also know this, all right? Now, if I ask you to find the sine, cosine, and tangent of an angle inside this right triangle. Let's see. Given, I give you one example here, okay? Given, okay, I give you, let's see, two sides. I give you A equals 4 and B equals 3. I only give you this. And I ask for find, it's a right triangle. Okay, I just put that as a condition. Ask you to find a sine A, sine B, cosine A, cosine B, tangent A, and tangent B. Can you do that? Can you find it? Let's draw this graph. Okay. AB, and so that's 4, 3, and connect this. So A is 4, B is 3, and so this is the B, this is the A, this is the C. So can you find this little C here? Yep, because the C square should be A square plus B square, which is a 4 square plus a 3 square, and that's a 16 plus 9, 25. Therefore, my C should be 5. So you know there's a 3, 4, 5 form, a very good, beautiful right triangle. So here, I'm going to write C equals 5. Okay, so this is the first step. If I give you two sides, you can find the other one. Of course, if I give you A and a C, you can also find a B. Okay, just using this Pythagorean theorem, you can find it. Once we have all those three sides, we are okay to find sine A. Here is a sine, here's an A, right? So sine A is the opposite over long. So that will be 4 over 5. Okay? Cosine A will be adjacent over long, which is 3 over 5. Tangent A, that's going to be opposite over adjacent. Okay? Now, let me do B. Sine B. Sine B. B is here. Opposite for sine, that's opposite. 3 over long. Cosine B is going to be neighbor, or the short leg neighbor side, which is a 4 over long. Okay, it's always the short over long. Okay, and then tangent B is going to be opposite over adjacent. There we go. You're done. Okay, so if I give you two sides, can you find the sine, cosine, tangent function for any angle here, A and B? Yeah, see, this is a good example. Now I want you to take a look at this. Did you notice that this sine B and sine A and cosine B are the same? Because this sine A is 4 over 5, and this cosine B is 4 over 5. So this are the same, okay? Which means if two angles add up to 90 degrees, then sine of one angle should be the cosine of another angle. And they're very similar, so you can see this, right? Okay, since A and B add up to 90 degrees, so sine of one angle should be the same as the cosine of another angle. Interesting, isn't it? Now look at this, tangent A and tangent B. And this is a 4 over 3, this is a 3 over 4. Therefore, if two angles add up to 90 degrees, their tangent value is the reciprocal of each other. Sounds good? Okay. All right. So this is, I give you the side. I only need to give you two sides, and then you can find the trigonometric function value of the two acute angles. Okay. Now, what about I give you one angle and one side. Okay. So I'll give you one angle and one side. So I will give you one angle and one side. I give you this is that was like a 38 degree. Okay. And I give you one side. Which one I want to give you? I'll give you this. This is a 5. All right, so again, A, B, C, let's label that. So far, this is everything I know. I put 5 centimeter. Okay, I give a unit of this length. Can you find all the rest? Can you find this angle, this angle? Of course, this is 90 degrees. We can just write it right there. Can you find this angle? Yep. Can you find this side and this side? Let's see. If you have this angle A, because A plus B equals 90 degrees, and A is 38 degrees, so your B should be 90 degrees minus 38 degrees, which is 52 degrees. So you can just write it here, okay, 52 degrees. Good. And for the other two sides, I don't really know. This is a little b. And A I don't know, and C I don't know. See that? And how do I find it? Let me just write this a little better, 38. How do I find this? For this little a, what I know as what we learned is sine A equals little a over C. Well, I don't know A, I don't know C, but I know tangent. So tangent A is A opposite over the neighbor or adjacent centimeter. Isn't it? And that is tangent 38 degrees. All right, now since you have this, your A is going to be 5 centimeter multiplied by tangent 38 degrees. Can you find it? Of course you don't. But anyway, we have this calculator. I'm going to use my iPhone calculator, but you can also use the TI-83, 84, or even Desmos, whatever calculator that you feel comfortable to use, okay? So this is, I think I tried to put everything here. And I want you to pay attention to here. Sine, cosine, tangent. This is a scientific calculator. So sine, cosine, tangent. Those are the three we're going to use today. And also there's another thing I want you to pay attention is this, RAD. Okay, now you hit that. Did you see that? It shows RAD. That's the measurement in radian. And then if you hit degree, then we're using degree. So the good thing is right now it's a 38 degrees, so we just use it, okay? I don't need to convert to the radian to do that. So it's going to be 5 times tangent. So after you hit tangent, automatically give you this parenthesis, and open the parenthesis, and you just put a 38, and don't forget you're going to close that. Okay, so that's the 5 times tangent to 38, and with the unit of centimeter, you hit equal. So if I ask you to keep 2 decimal places, you're going to get a 3.91 centimeter. Isn't it cool? I got a 3.91 centimeter is my little a. So that is a 3.91 centimeter. That's nice, right? Okay, so it's a very good thing. And then what about a C? C is, for example, I have this A, which is the neighbor or the short side is 5, and the C is there, so it's going to be cosine, right? Cosine is the short over long, but not the opposite, the adjacent over long. So let me write that. Cosine A is going to be 5 centimeter over C. Okay, therefore cosine, my A is a 38 degree, equals 5 centimeter over C, and then I'm going to multiply by C on both sides, so this is C is gone, and then I divided by cosine 38 degrees, so I got a C should be 5 centimeter divided by cosine 38 degree. Let's see what is that. Okay. So that's going to be 5 divided by cosine, and automatically open this parenthesis. You just put the degree inside and close the parenthesis. So that's a 5 over cosine 38. Okay, so it's a 6.35. Don't forget centimeter. So that's a 6.35. Therefore, that is 6.35 centimeter. Did you solve this triangle? Yes, you did, because you have the degree, you have a angle A, angle B, angle C, you have the side A, side B, side C. So this is how you solve a triangle. If I give you one angle and one side, it doesn't matter which one, as long as you have a one angle, not this one, because this one is given. Okay, right triangle, we should know that. Okay, so that's how you solve a triangle. Now, I would like to ask you to know a little bit more about a right triangle. There are two very special triangle. One is called isosceles. Isosceles triangle is this. It's this side and this side are the same, and then you connect that, right? So here is 90 degree, therefore here should be 45 degree, and here is a 45 degree. And if this side is 1, this side is also 1. And what is this side? So that's the little c. We know c squared equals a squared plus b squared, which is 2. Therefore, my c should be root 2. So for this 45 degree, you have a 1 root 2. I want you to remember this this ratio, okay? And the other one is equilateral triangle. I don't know if you remember that. It was like this. So this side, this side, this side. You saw this. So therefore, each one is a 60 degree, 60 degree, and a 60 degree. But if we want to know something about a right triangle, so we just cut that into half. So we're going to have this triangle. This is also a very useful special triangle. So here's a 60 degree, therefore here must be 30 degree. Okay? And this side, they're the same, but this one, I only take half of that. So if I use 1 unit as this base, or that this length, then this must be 2, right? It's twice of that. So what about this one? This is, let's say this is a b, and then that's going to be 1 square plus b square equals c square, which is 2 square. Okay, so this is 1, subtract that, so my b square will be 4 minus 1, which is a 3. Therefore, this is going to be root 3. So 1 to root 3, that's another ratio for this 30, 60 degree right triangle. So those two are very, very special. However, I want you to know this. This is the angle. Okay. 30 degree, 45 degree, and 60 degree. Okay. Angle A. And what is the sine A? Okay. Angle A. Here's a 30 degrees. Sine is 1 over 2. It's 1 over 2. Okay. What about cosine A? Cosine A is going to be root 3 over 2. So it's root 3 over 2. What about the tangent A? Tangent A is going to be 1 over root 3. Or you multiply by square root of 3. So here's going to be a better way to express that, which means you don't have the square root sign in your denominator. So this is your final expression. Okay? Okay. Now, 45 degree, what is the sine 45 degree, which is 1 over root 2, or root 2 over 2. And a cosine 45 degree is also this over that. So it's the same. So it's a root 2 over 2. Tangent A, which is this over that, so that's just 1. Okay. Now 60 degree, which is here. Remember 60 degree and 30 degree, they are complementary because they add up to 90 degree. So sine 60 should be the same as cosine 30. So that's root 3 over 2. Let me double check. 60 degree, is that a root 3 over 2? Yes. So this is 1/2. And the tangent of that should be this, root 3 over 1. So that is root 3 over 1, and which is just the reciprocal of the other one. So these two most frequently used, or a very special right triangle. I want you to know this right away. Other than that, I also want you to know this is pi over 4. This is pi over 6, right? Pi is 180 degrees, and this is pi over 3. Okay, so keep in mind that you really need to be very, very good at this, okay? All right, now we're gonna work on some real question. Let's see, how do we solve this question? For example, you're hiking somewhere. Okay, so you are the little person, stay here. Okay. I should put your eye level here, but it doesn't matter. Let's just do all the measurement here. All right, now you look at some place, there is a mountain, and here is like a big, I don't know, it's a big pole. All right, now starting from here, this ground, if you look up, not look up, you look from your heel. Okay, so let me just, this is horizontal line, right? If you look up, this is called elevation. All right? And this is called depression. Elevation gives you the degree moving from here to up, and depression moving down. Let's see, this is 25 degree. I give it that, okay. And I give you, this one is a 32 degree. This is the depression. When we talk about the depression, I just use the 32 degree, not the negative 32, because whenever I say depression, I know it means going down. All right, now, however, I know the distance from here to here is 500 feet. I'm asking, what is the height here? Well, this is very similar to the first example I give you. I give you a side and angle. Can you find another side? Let's assume this is angle A. I call this is A. This is a right triangle, right? Okay. This is angle A, and I need to know here, and I have this, so I'm going to use tangent. Sine, cosine, you're going to use this. Tangent, you don't use the long side, you use two legs. So tangent 25 degree is, let's call this is x1, I call this is x2. At the end, I just need to add them up. Okay, so that's going to be x1 over 500. Therefore, my x1 should be 500 feet times tangent 25 degree. Okay, calculator. Five hundred times tangent of 25 degree. Right now I'm using degree because I see the radian here, right? And then you hit equal. So that's 233.15. Okay. And then let's look at the bottom here. It's a right triangle, and I call this is B maybe. Okay. So my tangent of 32 degree, tangent 32 degree is going to be the opposite, which is x2 over 500. Another feet. Okay. So therefore my x2 is going to be 500 feet multiplied by tangent of 32 degree, which is, calculator, it's going to be 500 times tangent of 32 degree. Ding. I got a 312.43. Okay, so what is the total length or height, or the question mark? So my question mark, whatever you're looking for, should be just x1 plus x2 is 233.15 feet plus 312.43 feet. If you add them up, you should get a 545.58 feet. That's your answer. Okay, so the answer, when you give the answer back, then you should know, oh, that was the total height that you're looking for. See, if you know some information, if the information is enough, then you can calculate a lot of things. And the good thing is you have to know is elevation, depression. That's it. Okay. So what else we need to know? All right. Now let me give you one more question. Can you find this? This is a 4. Okay, so this is a 4, 13, and I give you there's a 5. Okay. Can you find all those 3 angles? This is vertical. If I only give you 4 and 13, you cannot do that, right? But however, if I give you 4 and a 5, can you find this side? Yeah, 3, 4, 5. Remember that? So this is a 3. And can you find this side too? Yeah, because of, okay, so 3, 4, 5. That is a right triangle. That forms a right triangle. Okay, and 5, 12, 13 is also a right triangle. So there's some right triangles that you might want to know. So this is going to be 12. Therefore, I know this is going to be 15. The total bottom here is going to be 15. Okay, and this here is not a right triangle, but here it is. Okay, can you tell me what is the angle here? So this is angle, let me call this A, this is B. So sine B, you tell me sine B is, sine B should be 5/13, isn't it? Okay. And then sine A is 5/4. All right. So later, in later chapter, we're going to find out what is B by taking the inverse function of this inverse sine. And then we find the value of A and find the value of B. And then we subtract the sum of that from 180 to get the angle C. We totally solve it. But so far, I just want you to know some information about here and give you this two sets of right triangle. And I think that's everything I need to tell you from the right triangle trigonometry. Okay.